All right, so we're looking at solving a trig equation. What I want to first notice for myself and remind myself that they want the solutions in a particular domain. So x is supposed to be in between negative pi and pi, so I'll highlight that so I come back to it later. The next thing I'll want to do is decide of my technique about trying to solve this equation. Notice that we do see a square on our trig function tangent. And that kind of clues us in to the fact that we're going to be looking at a quadratic equation. And so then if we have quadratic equations, then we try to see if we can factor them first. And then if we can't do that, we'll try to use the quadratic formula. But I'm really happy because I do see a 0 on the right-hand side of the equation. So I'm going to try to factor out the common tangent x from both of the terms. So if I do that from the first term, I'm left with the tangent x. If I factor out the tangent x for the second term, I'm left with a 1. And we still equal to 0. So now that we're completely factored, what we can do is set each of the factors equal to 0. That's the 0 factor property from algebra coming back to haunt us. So I have tangent x equals 0 or tangent x plus 1 equals 0. So then we have a nicer version of a trig equation to solve. What we're going to look at first, I'm going to look at tangent x equals 0. And we're looking for the values of x where the tangent is 0. And so what I'm noticing right here for myself is that that is a quadrantal angle. And what I mean by that is when we draw the unit circle, I'll draw it a little larger. What I'm trying to get at is that where the theta equals 0 would be about from here to here. And so if we draw the unit circle, I'll do the best I can. I am not good at freehanding circles, but bear with me. That is the theta equals 0. And you'll notice if you go higher to the top, you have theta equals pi over 2. See if I can write that nicer. Then I've got theta equals pi. And theta equals 3 pi over 2. So we've got our quadrantal angles. And we're interested in where the tangent is 0. So a lot of times if you want to remind yourself, just a quick reminder, definition of tangent, and I'm using theta because I don't want that to get confused with my variable in the equation. So tangent theta, definition of theta or tangent theta is y over x. And if you're looking at the ordered pairs for each of these quadrantal angles, we have 0, oh, sorry, what am I doing? We have 1 comma 0, 0 comma 1, negative 1, 0, and 0, negative 1 for this ordered pair where the unit circle meets the axis. And what I'm interested in is where do I get 0 when I look at the x and y values? So it just so happens, if tangent is y over x, we just take the y value. And anytime we have tangent x equals 0, we're looking at these two angles. So I'm going to start off with 0. Because if I were to take the y values, I'll just look at this one right here, if you don't mind. The tangent of the theta angle would be y over x. Y is 0, x is 1, so that leaves us with 0. That's what we're looking for. So that's what we're interested in, is the angle of 0, one of our solutions. And also, same idea, if you look at x equals pi, we also have the case of tangent of theta equals 0, because if we take the ratio of the y value, 0 over negative 1, we also get 0. So we have two situations where the value is 0. So if I look at this, I can actually kind of look at saying, hey, my x value will either be 0 or it will be pi in the range or domain, if you want to think of it this way, from 0 to 2 pi. Now, a lot of times it's helpful when we're trying to find solutions of trig equations. Sometimes we can combine this into all solutions. So if we look at all the solutions, reminding ourselves that trig functions are periodic, we kind of look at where the pictures are located. So we have x equals 0 and x equals pi. Those are the locations where the tangent is 0. So a lot of times you can start off with the least angle or the smallest angle. So we can say x equals 0 is the smallest angle. Now, if I add on, I do know I have to get to a pi. So if I'm trying to get to pi, you kind of think about, you can either add a full 2 pi, that's a whole circle all the way around. Okay, but the other solution, if you remember, tangent has a period of pi. So if you just add 180 degrees or pi, you're going to automatically hit that second angle, x equals pi. So what we like to look at, we have 0 plus pi times, and we're going to use k. That is, k is standing for the integer. So k is an element in the integers. And if we plug in all the integer values of k, we will get all the solutions. So this would be a good opportunity to double check your domain. Do they want it to be in between? X is supposed to be in between negative pi and positive pi. It can include negative pi, but it cannot include positive pi. So I have a feeling what I'll kind of start off with, if I have to include a negative number, if I am starting at 0, that means I'm going to try to talk about having k equal, we're going to try it with maybe negative numbers. So I'll start off with -2 just in case. And so if that is the case, I get x equals 0 plus pi times -2. And then if you were to work this out, what do we have? -2 pi. And you notice that that is not in the domain. We're looking for, it's actually outside. It's we're looking for negative pi to positive pi. So just kind of count forward with integers. K equals -1. That's equal x equals 0 plus pi times -1, which is giving us negative pi. And if we kind of look at our domain that they're specifying, we do want this one. So this will be a solution that we circle. We can list it later. Another integer, we're just counting forward, k equals 0. I'll use a little more space for you. X equals 0 plus pi times 0. Well, we get 0. And if you kind of look, yes, that is also in the domain from negative pi to positive pi. So we will circle that solution as well. And then we're going to try just counting another integer, k equals 1. Just double checking. Sometimes I pick more than I need. So I have 0 plus pi times 1. And that will give us pi. And I know that's reasonable, but we want to double check. We notice that our domain, it's not supposed to include pi. So we are done. We won't go k equals 2 or k equals 3 because that's not in the domain that they want. So now we have two possible solutions for this part of the equation. But if you remember, we had another equation to solve. That's where the tangent of x plus 1 equals 0. So we're going to take some time to develop that. Usually when I solve these particular equations, what I like to do for myself, I'm going to isolate the trig function. So I'll subtract 1 on both sides. So that is going to leave me with tangent of x equals -1. And right away, whenever I'm talking about the tangent of x being something with a 1, that's really going to clue me in. not the fact that it's negative, but the fact that you're 1, you are looking at a 45, 45, 90 triangle. If you remember what those are, we're trying to understand the tangent. And I talk about degrees for now. But remember, the sides are 1 and the hypotenuse has a length of square root of 2. And we kind of use a different version of the tangent. I like right triangle trigonometry. So what I'm looking at is, I do realize, reminder, that 45 degrees is equal to pi over 4. So it gives me an idea of what the reference angle should be for ourselves. Now, if you're trying to talk about tangent, another version of definition-wise, remember tangent of theta, also known as opposite over adjacent leg of the triangle, of the right triangle. Hopefully I spelled that right. It's been a while. Usually I just abbreviate. But if we're kind of looking at opposite over adjacent, it's not going to be the 90-degree angle, it's going to be the 45-degree angle. So what would happen is if we take the tangent of 45 degrees, or in this case, pi over 4, the opposite, looking at this angle, the opposite is 1, and the adjacent is also 1. So that's equal to 1. So we know that pi over 4 is going to be this nice reference angle. Once we understand that, I always like to draw a quick picture of all the possibilities because that takes care of the signs. So I'm back to kind of a fake unit circle in a way. But if I'm looking at my angles, I'm going to have pi over 4 that I'm going to refer to. But notice the symmetry with the unit circle is you can look at all the other pi over 4 instances in the quadrants. And so if we're trying to name these angles, I'm going to name them by the top part. Pi over 4 is our reference angle. So you can kind of see what I'm looking at. So I have pi over 4, 3 pi over 4, 5 pi over 4, and I should have 7 pi over 4. You guys recognize the patterns. You could also think that you're breaking up the circle into 8 different equal pieces, so you can use fractions to help you. So I don't know if you remember, if you have pi over 4, we really have 2 pi over 4, which we can reduce. Then we have 3 pi over 4, then 4 pi over 4, which reduces to pi, and so on. So that's kind of how I learned that when I was memorizing them. I like patterns as opposed to strict root memorization. Okay, so we have established that one of these angles or 2 of these angles could be the solution. We also want to remind ourselves, where is the tangent negative? So if you kind of look at, you can either look at definitions, or we have a nice trick that we have as well. So remember, a tangent is y over x. So that would be, where do we have opposite signs for our quadrants? So a couple of instances you can talk about. When you are in quadrant 1, your signs are positive x, positive y. When you're in quadrant 2, your signs are negative x and positive y. So this would be a case, because remember, if tangent of theta is y over x, if you have an opposite y and an opposite x, this would be a good case of a potential solution. In quadrant 3, we have positive, positive. Excuse me, why am I saying positive? Mainly because I know that we're going negative x, negative y. So that would make the tangent positive, same signs. In quadrant 4, any ordered pair is positive x, negative y. So that again makes the tangent negative. So that 7 pi over 4 is another potential solution. So we can finally say that our solutions, x should equal, according to the 0 and 2 pi, 3 pi over 4 or 7 pi over 4. Now, if you're kind of playing with the signs and just kind of thinking about the coordinates, that works. I also am a big fan of the all students take calculus. So I don't know if you guys remember the quadrant 1 is all students take calculus. All means all the trig functions are positive in quadrant 1. Quadrant 2, S stands for the sine and its cofunction. So sine and cosecant are positive in this quadrant. T stands for tangent and cotangent are positive in this quadrant 3. And then quadrant 4, we use calculus, but it really is cosine and secant is positive. So if you like that shortcut, feel free to use it, whatever works for you. So back to our solutions. We do know we have 3 pi over 4 and 7 pi over 4 as satisfying where is the tangent -1. If we want to speak about all solutions, what we're looking at is you could start off at the smallest angle. X would be 3 pi over 4. And if you want to think about how you're going to get back to it, you have some options. You can either add 2 pi back to it to get back to the same place. But we do remember, especially even the visual, that to get to 7 pi over 4, it's 180 degrees or pi. And that is the period of tangent. So again, if we're looking at 3 pi over 4, we'll add on pi times k. And I use k as standing for integers. I think sometimes people use n. I guess this is the way I learned it, so I'm stuck with it for the rest of my life. So k is an element in the integers. So again, if you're looking at your domain, they wanted x to be between negative pi and positive pi. We can start off. We know that we have to have negative, so I kind of go with 2's, but we can kind of investigate as we go. If we have k equaling -2, a little bit of fraction math coming our way. We have 3 pi over 4 plus pi times 2, -2. So we do a little math, 3 pi over 4 minus 2 pi or plus -2 pi, if that's something you like. Feel free to use your fraction key, ignoring the pi, but I do know that -2 pi, my pen is not catching, I apologize. I do know that -2 pi, if you find an LCD, it's 4. If we multiply by 4 over 4, we should get -8 pi over 4. And so this is going to give us -5 pi over 4. And if you notice, that is way too, not way too small for our domain, because remember, we're supposed to be in between negative pi and positive pi. So this would not be appropriate. And I'm just overestimating. Let's move on to k equals -1. And sometimes if you know you don't go too far enough, you can say, oh, I can go to k equals -3, k equals -4. But I'm moving forward because I do know I'm already outside the domain. So I'm going to look at k equals -1. And that would be, x would be 3 pi over 4 plus pi times -1. So again, a little fraction math for us, 3 pi over 4 plus -pi. And again, if we find an LCD, we multiply -pi by 4 over 4, we have 3 pi over 4. We need a little more space for ourselves. There we go. So 3 pi over 4 minus pi over 4, or minus 4 pi over 4. That's going to leave us with -pi over 4. And if you want to double check, is that in your domain? Remember the domain? Just kind of look back. I know it's a little easier for you all. I have to scroll back, but yes, it's in between -pi and pi. So x equals -pi over 4 is a good potential solution, or it's actually a good solution. So we're probably guessing. Keep going. We do have k equals 0. That's a nice one. So if we're going off of our solutions, x is equal to 3 pi over 4 plus pi times 0, which gives us 3 pi over 4. And if we look back in our domain, we realize, yes, that is also in that specified domain. So we can circle that. And then go a little further. K equals 1. X equals 3 pi over 4 plus pi times 1. And you probably already guessed this. If you're adding just pi, you don't really have to do the fraction math, but you can. But if you're adding just pi, we are in the situation where we're hitting the 7 pi over 4. So feel free. You want to kind of go through your fraction math or use your fraction key on your calculator. What do we have? Multiplying by 4 over 4, 3 pi over 4 plus 4 pi over 4 gives us that 7 pi over 4 like we guessed. But remember, that is not in our domain. That is outside of pi. And you can kind of see it in the unit circle, because if you're going from negative pi to pi, we're way too far when we see this. So finally, this is actually leaving us with our final solutions. So if you're going to list your answers, I know there's a lot of work. I'm going to shrink it down for you. Our final solutions . See if I can. I'll write a little larger. If we're going to list them, we would have, see if I can list them in order. Negative pi, then we have negative pi over 4, 0, and 3 pi over 4. To solve that equation, and remember the domain was supposed to be in between negative pi and positive pi. So finally, we actually have the solutions to our equation. So there's like a lot of busy work. I know I just showed the stuff to find the particular solutions using the all solutions by hand, because sometimes that's useful. I do realize there's shortcuts, but hopefully this helped. One of my hints is to always kind of draw a picture of where your potential initial solutions are, or they call them fundamental solutions, and then kind of use your all solutions to deal with that later, and then use K to help you figure out the rest of them. So I hope this helps, and maybe I'll see you in another example.